All right. So today we have Aurimas Griciūnas, Chief Product Officer of Neptune.ai, Neptune.ai. Tagline is the experiment tracker for foundation model training. And more descriptions from the website. If it's not responsive, it's not working. It's hard to iterate fast enough on massive model training when your experimental tracker lags behind you. So I think the general theme of our conversation will revolve around scaling LLM Ops. So with that long-winded introduction, Aurimas, welcome to the podcast.
Hi, Ben, and thank you for having me. Super glad to join and talk to you.
All right. So I guess people are familiar with the term ML Ops. So is it fair to assume that LLM Ops is ML Ops for LLMs at a high level? So let's get that out of the way, right?
Yeah, that's quite true. And, with Neptune, there's a little bit of history behind it because we started like 6 years ago when MLOps was still a thing. Now LLM Ops kind of overtook everything, right? And we are kind of, as a company, really focusing on the experiment tracking piece of MLOps. So we are not really doing the whole cycle. But in general, we definitely support at least half, I would say, of LLM Ops lifecycle as a tool.
All right. So we're particularly going to focus on this conversation around scaling out LLM Ops, right? So obviously the L in LLMs is large, so there's scale implicit there. So what specific problems or challenges does LLM scaling face when you try to use your traditional tools?
Okay, so I'll try to also put it into a little bit of a storyline, what has happened after kind of we started off and then we moved throughout the 6 years, right? So we started 6 years ago where regular ML was the thing and everyone was implementing regular ML in production. And I would say the piece of ML that would be the only one that would require real scale or real-ish scale would be reinforcement learning, where you really want to run multiple agents and then log quite a lot of distributed data to your experiment trackers. And a lot has changed 2 years ago when people started training large language models at scale. And what has happened? That research became production, right? Because previously we had really a separate, I would call, set of professionals running and training machine learning in production, and separate set of researchers figuring out new ways to make machine learning more powerful, right? And now we are bringing this kind of research piece to the machine learning world and at scale. And researchers are joining all of these hyperscaler LLM Ops companies that are, LLM companies that are training their own foundation models. And you have sometimes tens, sometimes hundreds of researchers in a single company running these experiments to bring to you the newest kind of version of this large language model, right? And on top of that, there are these frontier models like GPT 3.3, GPT 4, etc. That where now a training of a model is becoming more of a production workflow rather than experimentation, because you only have one chance to train this huge model, and it takes to train not day, not 2 days, but now a month, maybe a few months, right? And you can only do that once, and you cannot fail. So this kind of brings, I would say, a healthy amount of paranoia to the teams that are actually running these long running training jobs. And they want to track a lot of metrics for each of the layer. So we compound those two elements together, and then the amount of data that you really need to log explodes. So it can be thousands, and it can be tens of thousands or even more unique metrics that you want to observe while the models are being trained. And you need to send them to the system in a really, really kind of high throughput way, right? Because the amount of data is really big. And that really hit, I think, the tools that were in the market and are still currently in the market, including Neptune, because we were not initially built for this kind of scale, to support this kind of scale. But we have identified this issue, and we have rebuilt our entire core to be able to ingest this vast amount of data. And this is just one of the dimensions, I would say, of scale that are now really important in these kinds of training, tracking processes that are in the market. Because another piece of this is that once you actually ingest this vast amount of data into your systems, you need to be able to visualize it in a very fast way. And it's not just because you want to just visualize it. You have 100 researchers that are spending their day-to-day, basically the entire 8 hours probably just looking into the charts of interest to see how this training is performing. So you want to render all of that data in a precise way, meaning that you cannot lose any data while rendering it, right? So if there are some anomalies in your metrics that you track, you need to be able to spot all of those anomalies because they might signal some error in the system. You need to do that fast, and also you have tens of thousands or hundreds of thousands unique metrics in the system. So you need to find the stuff that you're interested. So there's scale all over the place, right? You need to have performance dashboards, you need to find the data, and you need to ingest that data into the system.
And let me ask you in a minute about aspects of this that might be of interest to enterprise customers. But very quickly, Aurimas, at a high level for listeners who are not interacting with the people training frontier models, can you describe kind of like the scale that we're talking about here? Like how large are these clusters? How long does it take to train a decent LLM? And and so on and so forth. So in other words, so most people, their interaction with LLMs are either fine-tuning it, if that, or actually directly using it. But all they know is supposedly these models cost a lot of money and take a lot of time to train. And so give us just like a high-level description of the world of training frontier models.
Yeah, so it's changing and growing rapidly, right? So I don't have specific numbers, right? But the newest news is that companies are building clusters of 100,000 GPUs and more now. Actually, insider news are coming out all over the place, but the companies are starting to to use cross data center training. So 100,000 GPUs is not the limit anymore. People need more. The companies need more. Of course, these are big clusters. No one is saying that all of that compute is being used for just training, right? I would imagine the companies that are utilizing these clusters, they are also probably
serving the models,
dedicating at least half of it for inference, right?
Yeah.
So it's, but yeah, okay. So the clusters are huge. Talks now talks are about 100,000 GPUs. I think it will increase. It will increase quite a lot, and the training time is usually months of these frontier models, and you are burning those maybe 50,000 GPUs for a month to get the final results. That's also why you cannot fail, right? Because if you fail, you will need to burn all of that, all of those GPU hours again.
And then the Aurimas usually, so let's say Llama 4 comes out. By the time it comes out, that Llama team is already thinking of Llama 4.1 or Llama 5, right? So then that's why it takes, maybe they only release 2 of these models a year.
Yep.
Because they still also have to kind of make sure it's aligned, and they do some red teaming, and so there's a lot of post-training work that needs to be done as well, right?
That is true. And, I don't know internals of how Llama models are trained. So they are pretty open. But for example, with GPT, right, GPT-3 and GPT-4, we're kind of, I would say, falsely convinced that those models are trained really fast, right? Because with GPT-3, I think GPT-4 came out months after GPT-3 almost. While it was actually trained for more than a year, I think, in total. Just
and
before.
then there was GPT 3.5 in between, right?
Yeah. But those models are not trained that fast, right? It takes. So Llama guys, right? They are doing, I think, a pretty amazing job because they are doing it quite openly. So I think they are actually doing it sequentially. So we trained Llama 3, and now we are training probably Llama 4, and we are doing it sequentially. So I think it will take for them at least, half a year and probably a little bit more to come up with something. Where the actual post-training work, I do believe it's longer than the pre-training itself, but it's not in a sense of how much infrastructure you're actually using. So the post-training work, I heard it from Mistral, for example, that it's taking at least 10 times less time, the actual fine-tuning itself, right? And 10 times less infrastructure to do that. But it's already at this point in time, it's not just the entire internet data that you're training on. So the amount of time that you're spending on it is actually preparing the data sets that you're doing reinforcement learning with human feedback on. And as you mentioned red teaming and involvement of huge amounts of people, right, in the process.
There's so it seems like the post-training is cross-disciplinary, just a lot more coordination of teams, right? So let's go back to this notion of scaling LLM Ops and pre-training, especially pre-training of these frontier models, right? So obviously, as you know, there's only a handful of teams who are actually doing pre-training. So why should people who don't do pre-training care about scaling experiment tracking? Does that impact them, or so to what extent does some of these pain points, do you think some of these pain points will eventually have to be things that teams in regular enterprises need to pay attention to and care about?
So I wouldn't say that there are not that little amount of teams actually training their own foundation models. Not all of them are that large. Right?
Actually, let me just correct myself there, because we tend to think of the frontier models as these handful of really high-profile LLMs, but there's a lot of frontier models that are less known, that are much more specialized, let's say for coding or for image generation and things like that, right? So, but I guess it's not the regular enterprise that is doing that at the moment, right? So,
not a regular enterprise. Yes, exactly. Those more of a Silicon Valley companies that have already seen success, right, and have the money to actually train their own models. Okay. Yes. So that's true.
But there might be lessons that they can learn that regular enterprises might be able to glean from all these kind of trial and error and experiments that these frontier model teams are doing, right?
Yep, that's true. So we have introduced some specific features that are meant for large language model training, we would say, like for long-running experiments, that could also be used for other types of training jobs. So anything that where you're experimenting in time and want to, I would say, experiment by branching from a specific checkpoint in time, right? Because this is something that is done a lot with these large language models, where you're training your model, and then at some point in time, you decide to branch few experiments from a already continuously running model, right? And then you're doing multiple branches throughout the time, and sometimes abandoning one of a branch while continuing another branch. And
Is
it
this,
is
Aurimas, is this what you're describing here could map over to fine tuning, right? So in other words, I did some fine tuning in the past, and I want to pick up on that specific model and refine it even further.
100%, 100%. It could also be used in reinforcement learning to some extent. But there's one thing about this specific feature, is that it's really hard to implement at scale, because you need to, while doing these kind of branches and forking, you need to inherit a lot of data from your previous running jobs. And there's only a handful of companies that actually nailed it. And one of them is Google. Google notoriously, like they are known for having these kinds of features in their internal machine learning platform. And when these companies that are training large language models are actually coming to the market, they were looking for something like this. And it is definitely something that can be transferred to teams that are doing more regular machine learning. Also, what we saw, not necessarily what we saw, but
Or
we
even,
had,
or as I mentioned, even fine tuning, because fine tuning is something a lot of companies are doing, right? So,
yeah, but fine tuning is almost, I would say, fine tuning is adjusting your model, aligning it to a specific data set. But even continuing the pre-training is kind of
but
the same procedure, right?
but I guess what I'm saying is you can take a fine-tuned model and continue it,
Yeah, 100%.
right?
And see the entire kind of inherited chain of what has been done on it, like to be able to track the lineage of what you're currently running in production.
And more and more companies will need to get better at fine-tuning models, right? Because a lot of these frontier models may not specifically fit their use case. And so then they might also need to save a lot of these fine-tuning artifacts for whatever reason, debugging, compliance, all sorts of
100%.
reasons. By the way, Aurimas, earlier on in the conversation, you alluded to visualization, right? That there's
Yep.
a lot of metrics you have to visualize at scale, sometimes in real time. So what
Mhm.
are there some specific innovations that you folks have done around visualization? Because as you know, visualization, one of the challenges is you have high dimensional data, but our laptops only have 2 dimensions, right?
Yes, so
Yeah.
that's true. So I think the main challenge that we faced is naturally the amount of data that you want to visualize. And you have these massive charts that sometimes try to squeeze 100 or 200 lines on a single chart. And you want to display a series of 1 million length, like 1 million steps, right? And then um, it's impossible, to fit. Sometimes it's impossible to fit the data on screen. Sometimes it's just too much of the data. So we do some, I don't want to say downsampling, because when you say downsampling of data, then you're usually implying that you're losing some information about it.
Losing some kind of resolution, right? So
Yeah. But we are losing resolution, but at the same time, we are actually precisely calculating the statistics in the bucket that we are downsampling to, right? So if you're, let's say, logging 1 million data points and you have one data point somewhere, which is an anomaly, we are always visualizing it. And in order to do that, it requires some innovation. So we always were able to do that with our internal data structures that we create. But when changing our platform to support the hyperscale that we currently do, we actually swapped the entire backend, all of the databases. We changed everything and rewrote our entire backend to do that on even more massive amounts of data.
So let me ask you this same question in a different way, right? So if I put you in the spot under pressure, right? So,
Yeah.
and I ask you, so give me 1 or 2 stories where someone went into Neptune.ai visualization and saved the day on a training run. They saw something in there. Oh, wow.
So there are quite many, and again, I will fall back to stories of training LLMs. So I don't even want to take one and say tell one story, because these stories are all over the place. Because the way LLM trainings are tracked is different. There are a few important aspects to it. So first of all is that we are training on massive GPU clusters, and they are, breaking, right? And since we are, you very often need to restart your training runs. And when you're restarting your training runs, you're usually restarting from some historical checkpoint. Like it could be, just for reference, 100 steps in the past. It could be more. Doesn't really matter for this example. But what you expect once you restart a run is that the metrics that you have logged for this intersecting period of time, right? So let's say step 1,100, and then you restarted from step 1,000, and then you have this 100 steps that are overlaying. You expect them to perfectly overlay for most of the metrics that you're continuing to log, right? Because you provide some random seed, and then you expect that behavior. And then once you're restarting those training runs or faulty GPUs, you might have some errors in the restart procedure itself. You can have errors in the code. You can unintentionally provide a different set of configurations. And then you need to catch all of these, let's say, anomalies that are happening when the restart is happening. And this is a new thing that was not important in prior MLOps, right? Because now infra people are looking for these kind of errors, and they are happening all around, right? And once you find something where those curves are not overlapping, you know that something's wrong, and then you need to investigate. So I would say that we are saving the day quite often, but we don't know about it ourselves. We know what the process of saving the day looks like.
So is there any specific, because of the nature of the problem and the scale of the problem you're trying to solve, are there specific things that you had to build in order to store, retrieve, and visualize this data for experiments so that it's performant, fast, and it's not bottlenecked? Or are you just using standard open source tools?
They are open source, yes. When you see standard, probably yes, in high throughput systems, like high throughput distributed systems. What's different, let's say, when you compare Neptune, let's say, to some of our other competitors like Weights and Biases or Comet, right? So we integrate through Kafka, right? And we have rebuilt our system to be more of a asynchronous rather than synchronous ingestion. So it eventually became eventually consistent system, right? But non-visually, like you will not be able to see, but it's eventually consistent. But we have changed it from fully consistent to eventually consistent.
Interesting. So really big data problem using big data technologies. What about around the issue of fault tolerance, right? So usually when people do this kind of training runs at scale, they use a a framework like Ray, which has fault tolerance built in. So a fault tolerance, I think, is a must. But then
Mhm.
you also mentioned checkpointing. So I assume that you folks have built tools so that it makes it very easy and natural to do checkpointing as well, right?
So we are not doing them itself. So we are still keeping this, I would say, uh, nice piece of the puzzle to be solved to the companies themselves, because each of the company
Has their own way of doing it.
has their own way of doing it. So we are not planning to, solve it for them, because we are
But
best to do that.
but wherever they checkpoint, you kind of record that, and then you
Yeah.
make it easy for them to kind of restart their.
Yes.
Yeah.
Yes. Yes. So we're not discarding any data. So if you're training, let's say, for 1,000 steps, and you want to go back 100 steps and restart from specific checkpoint, we are not discarding that data for the initial run that you were training. We are rather supporting the forking capability from a specific point. So in this example, that would be from step 900, and then you still retain the data that was initially logged, but you restart the run and then you continue logging to the same experiment. So this is that forking capability that I was previously talking about. Then it comes to fault tolerance, you mentioned, right? So we take it really seriously. We built the system in such a way that we do not lose any data at any point in time. And even if Neptune's backend systems kind of go down, we always are able to replay the data that has been pushed to naturally Kafka, right? And the writes that we do are always idempotent, so you will never overwrite any data. Uh, you will always get the same state basically that you expect.
So one of the problems that even the people building LLM based apps or Gen AI based apps, right? So they're not pre-training models. They
Mhm.
might be fine-tuning, they might be using RAG, but one of the uh, problems is eval, right? So
Mhm.
evaluation, because basically, I think basically, I had a recent conversation with Andrew Ong, and he was saying, it used to take you 10 weeks to build a decent AI app. Now it takes you such a short time. Now, if you tell that same team that's taking 1 week or less to build a decent or like a seemingly decent app, hey, I need you to take 10 weeks to do eval.
Yeah,
They
yeah.
don't like that, right? So before he said, it would take you maybe 10 to 20 weeks to build the app. And then, so when you tell someone, yeah, take another 10 weeks to do eval, that's reasonable. But in your case, in the pre-training world, uh, can you give us a high-level overview of what these teams are doing in terms of eval and knowing when enough iterations is enough?
So they have their own internal evals naturally. So I don't think that we are using too much of publicly available ones. Of course, you're fine-tuning your models, I guess, to uh, beat the leaderboards, right? Eventually, but
Yeah.
the model is useless if you can only do that, right? You
Yeah,
need
you
to have your
cannot
in.
you cannot release a new model and say, "Hey, we actually are worse at these leaderboards than the other
Yeah,
models."
yeah, but we don't have visibility into this is very proprietary data, right? The internal evals and how and when do you actually stop? So I cannot, unfortunately, give specific information about it. Um,
Yeah, yeah,
yeah.
yeah. So what about let's see. So as we enter the world of, so agents,
Mhm.
agentic AI, what does an experiment tracking tool have to do with that?
So when it comes to agentic AI, we are not really going into that specific space. Um, but I personally, have my own opinions and insights into this area. So, but it really is, you could say that experimentation of these kinds of systems is now brought to observability and evaluation platforms, right? Because everything kind of starts with observability, I think, in agentic world, so in GenAI based applications. And everyone is now focusing on the tracing piece of it, because actual tracing in these systems brings a lot of granular information that can be then evaluated.
Especially
correct?
becomes important in multi-agent scenarios, right? So
I would even say multi-agent, it becomes difficult,
yeah,
but it is as important in all non-multi-agent environments. So a workflow is, you build your own system, you have your own golden maybe data sets, you have your own evaluations, you perform your prompt engineering, you build a system that you think performs, and then you deploy it to production. Once you deploy it to production, you start properly tracing it, as in regular software systems, right? The difference is that you're also running those evals on the spans in the trace. Some of the spans require evals, some of the spans are just regular software type of spans, right? So you just measure latencies, etc. But anything that has some non-determinism, each span that has some non-determinism in it, you need to evaluate. And then you're looking for those eval values, metrics that are going off, and then you kind of bring that data back to the first step of your tracing pipeline, and then you use it. I would say augmented version of it you can use to fine-tune your models and improve prompt templates in your prompt engineering step. So it's kind of experiment tracker, right? But for the GenAI systems. When it comes to multi-agent systems, it becomes extremely difficult. In general, it depends on what kind of agent you are building, right? Is it
very narrow and targeted, right?
Yeah, exactly. Or is it a general purpose agent that
the general purpose Aurimas, I think, is a bit of a science fiction right now in my mind. Yes, it works,
yeah.
but it breaks a lot too, right? So, but narrower agents seem more realistic, you know.
I would even say that those talks about multi-agent systems are not even necessary yet, right? Because you can say that you're building those specialized agents that can solve a simple task, but and then you have a smarter agent in the center that controls that, all of that. But it brings its own complexity. You need to track those interactions, you need to trace them, and then evaluate each of the agents separately. I think that currently we can still deal with most of it in a single kind of agent, which is more comprehensive and bigger and more complex, but solves the problem.
So you specialize in LLM Ops for training frontier models, right? So, but if I were to put you in front of an audience of enterprise AI teams, and I ask you, hey, Aurimas, give them 3 things that they should think about in the area of LLM Ops right now, what would they be?
Enterprise teams. Okay, so for enterprise teams, I would say definitely not pre-training of your own foundation model. So that would be first, focus on proper prompt engineering. Second, definitely implement guardrails in your application, very oftenly forgotten. And you definitely need observability. Like, you need observability in your system. So if that would be free, that would be this. And then only after you nail your regular prompt engineering flows, you have your guardrails in place, and you have observability. And observability by itself is a big topic because it involves evals, defining the evals before you actually deploy something. I think those 3, and agents would come as a 4th, maybe, right? First. Depends on the use case, of course.
So in your case, right? So models continue to get bigger, right? So regardless of what people think, scaling loss, seem to be still the North Star for most of these teams, right? So, so the models will get bigger. I mean, the people are trying to use even more data. There's a lot of dark data that may not be available in the public web. People are starting to do clever things around very, very kind of targeted use of synthetic data. So, in your case, in your day job, you're going to be faced with even bigger and bigger models. The models that in the future will be multimodal, much bigger, much more capable. So what are the challenges that you and the rest of Neptune are working on in terms of scaling LLM ops? What's on your to-do plate in the next 6 to 12 months?
That's a very good question. So I think that we already nailed the ingestion and retrieval piece. So we are able to ingest vast amounts of data and display it. But the scale itself brings more challenges, like how do you find data in the app that you need to find, like just very comprehensive filtering capabilities inside of the app. So the first one. The second one is how do you even notice things happening when you have hundreds of thousands unique metrics logged, right? So experiment tracking platforms in era of LLMs are also becoming experiment monitoring platforms. So that would mean for us that we are most likely, very likely to implement some monitoring capabilities, alerts, some thresholds where we would alert you on, including some intelligent anomaly detection in the app itself, right? So that we figure out stuff happening before you yourself figure it out. And it very well kind of, I think, connects with this idea. I heard it multiple times from those people from these big labs. The question is, why and how are the researchers that are actually training these large language models valuable, right? And it seems like they are valuable because the longer you deal, the longer you actually work in this space, the more patterns you learn, the more you understand what works and what doesn't while training these models. So I do think that this knowledge could be somehow also embedded into the experiment tracker. So either through figuring it out automatically, or for these researchers being able to actually define the rules for what we should be looking for, so that we don't need to look into the data so much, right? So that it will be automatically surfaced for you. So basically increasing the efficiency of work of researchers and the actual operations, not operations, but platform people that are observing the training is kind of our goal. So monitoring, alerts, anomaly
One of the
detection.
things that you mentioned earlier, right? So the scale of the clusters, right? So 100,000 GPUs, now maybe sometimes involving multiple data centers. It seems to me that there's so many challenges right there and there, right? So you can imagine someone firing up such a humongous cluster. There's so many things going on, and the cluster may span a couple of data centers. So you folks will have to track all of these metrics. So you will have to deal with the network topology, bandwidth, all of these things, right?
It really depends on how the companies implement their experiment tracking, right? So you could be first, like usually everywhere you gather your data first in the driver, right? And then you calculate some aggregations and use them for analysis. But definitely I see, I think a wave coming where companies will want to track per GPU data, including some.
Because you can, like you said, right? So these experiments are expensive to run, and you want, if there's going to be a problem, I want to know the problem as early as possible.
So this is I would say hardware monitoring, right? Problem when it comes to identifying when the GPUs are to be kind of to break, right? We are not necessarily planning to go into the hardware monitoring space that deeply, but definitely collecting metrics per GPU, which might explode the data collected thousandfold.
Wow.
Yeah.
Interesting. So by the way, so let's close this conversation by let me go back to fine tuning, because that's much more of a topic that enterprises can relate to. There's also this notion of full fine tuning, where you actually kind of fine tune the entire model, not just subsets of the architecture. And if you're a much more ambitious company wanting a much more capable and domain specific model, do you think this will be within the reach of enterprises in the near future, where they can be much more ambitious in how they approach fine tuning? In which case, they would need a tool like Neptune, right? So right now, it seems like a lot of the fine tuning that people do seems very, very kind of targeted and task specific, right? So, but you can imagine, hey, I'm much more ambitious. I want to fine tune a model more broadly for my domain, in which case I would need to do much more serious experimental runs, in which case I would need a scalable experiment tracking system like Neptune. So the question for you is, am I correct in thinking that maybe actually there's more companies who might go down this path than we think?
So actually, there are more companies going even the path of training their own foundation models than we think. Definitely than we initially thought when we started this project.
And these are
so
outside of the tech companies, right?
like they are tech, right?
Yeah.
But not
But you can
not the
imagine
companies that
you can imagine a really large financial services company in the future might do something like this.
yeah, exactly. So these kinds of companies as well, right? Not only companies that actually just train models and provide them via APIs. So more like regular enterprises. And when this comes to fine tuning, yes, Neptune as well. So first of all, maybe very worth mentioning is that we didn't lose our general purpose with Neptune, right? Neptune is still can still be used as a general experiment tracker, like weights and biases, or any other of our competitors. We simply now support scale as well, right? Yeah.
Interesting. So in closing, Aurimas, is there one trend in AI that you're particularly interested in right now? It doesn't have to be related to Neptune, but what are some trends that you're super keen on?
So I initially I was and still am believer of these agentic systems eventually, right? Not yet, but at some point in time. And what I really looking forward is, so first of all, these agentic systems need the brain, right? That LLM that basically plans the steps for these systems to take. And I'm really looking forward for the next breakthrough that everyone is talking about, right? So this Strawberry, etc. projects that are kind of predicted to crack reasoning. I think that these kinds of systems would not only be more powerful as a LLM in general, but would also fit these brains of agentic systems very well as well, because we are now being kind of trained on these instead of just having internet data where we have a snapshot in time, right? We have some research done, we feed it to the LLM, and then we train on it. Now we know about those models being trained on reasoning data, right? You have an actual reasoning chain created specifically for this use case, probably internally by the companies themselves, right? And then those models should be able to perform these reasoning tasks a lot more efficiently. So I'm really looking for the synthesis of the two. So very strong agents because we are cracking the reasoning aspect of the actual LLMs themselves, right? So that's what I'm looking forward a lot in the next few months, not few months, maybe half a year.
By the way, returning to contemporary things right now. So, as you know, one of the hot things right now is RAG and GraphRag, and those involve running experiments as well.
Yeah.
People don't realize this because there's many knobs you can tune in order to get these systems optimized, right? So, do you folks help people to track their RAG and GraphRag experiments as well?
So not Neptune. We are
Not
not.
Neptune.
We are really now focusing down a lot on these hyperscaler
Hi.
teams that are training the LLMs
Yeah.
from scratch.
All right. And so with that, thank you, Aurimas.
Thank you, Ben.